Assalamualaikum and a very good day to all of you. My name is Muhammad Elhaki bin Azhar. I am 4-year undergraduate student of Bachelor of Science degree in Industrial Chemistry. Today I will present about my final year project given title Photodegradation of Organic Dyes using gold cluster on titanium dioxide as photocatalyst. So firstly, as an introduction, I will explain about photodegradation. Photodegradation is defined as degradation of photodegradable molecules into simpler fragments under absorption of photon. So photodegradation of dyes have been extensively used in oxidative degradation of various dyes. It has been used for a long time. This is because photodegradation technique is cost effective and non-toxicity. The rationale behind photodegradation is the generation of charge carriers, which is electron and hole, that are responsible for dye degradation. So this is the illustration of photodegradation of dyes, where the visible light will strike on the surface of gold, supported by titanium dioxide photocatalyst, and it will produce degradation products. Okay, now we move on to dyes. Dyes is a substance that will provide color when applied to any substrate. The dyes possess two groups of atoms. First is chromophore, group of atom that is in charge of control of the color of the dye. Then next one is auxochrome. Auxochrome is the group of atom that attached to chromophore, that is responsible to alter the wavelength and intensity of color produced. There are various types of dye, such as azo, VAT, reactive, acid, sulfur, dispersed, basic, and direct. Okay, next I will explain the harmful effect of dyes. Dyes is an important ingredient in textile and clothes industries for fiber coloration. So the market for textile and clothes industry growing exponentially over the years. So the high demands from customers and suppliers will lead to increasing the production of dyes worldwide. Along the production of dyes, there will always be the field dyes. So the remaining dyes will be discharged to wastewater as an effluent. So the untreated dyes will have a huge impact on environment, such as it will affect water quality, that will rising biochemical and chemical oxygen demand. It will inhibit photosynthesis process and harming aquatic life. Okay, now I will explain about titanium dioxide. Titanium dioxide is most commonly used as a photocatalyst. Titanium dioxide consists of three crystal polymorph: anatase, rutile, and brookite. Why titanium dioxide is the best as a photocatalyst? This is because it has wide band gap, 3.0 electron volt for rutile and 3.2 electron volt for anatase. This wide band gap allows the titanium dioxide to absorb UV light, including doping metal ion. Okay, now I will explain about gold. Gold is a soft metal which can be considered chemically unreactive. However, small gold nanoparticles has high catalytic activity. Few study has shows the potential application in photothermal therapy and optical manipulation for gold nanoparticles. Gold possess unique properties, which is surface plasmon resonance. It occurs during the interaction between light at specific wavelength and frequency and conduction electrons in gold nanoparticle. So, coupling gold nanoparticle with titanium dioxide can help to improve the photocatalytic activity. Then we move on to the problem statement. Our problem in this research is the wide band gap on titanium dioxide is only 3.2 electron volt, which limits its usability to absorb visible light. Visible light wavelength is in range 380 nanometer to 700 nanometers. Other than that, titanium dioxide also has fast charge carrier recombination, which can lead to low catalytic performance. our solution for this problem is to couple the titanium dioxide with gold nanoparticle. This is to create the heterojunction photocatalyst. Besides, it can also extend the light absorption in visible regime, and it can reduce the rate of recombination of charge carriers. There are three objectives in this study. The first one is to prepare photocatalysts by depositing gold cluster. We use gold AU9 and AU101 on anatase titanium dioxide. The second is to study the photocatalytic performance in degradation of dyes. We use three different dyes: methylene blue, methyl orange, and rhodamine B, using gold and titanium dioxide photocatalyst. The third one is to characterize the physiochemical and optical properties of supported gold cluster catalysis using high resolution transmission electron microscopy, or HRTM, X-ray diffraction or SRD, UV visible diffuse reflective spectroscopy or UV vis DRS, and photoluminescence spectroscopy, PL spectroscopy. Then the characterization of photocatalyst. HRTM or high resolution transmission electron microscopy, we use it to analyze the shape and size of gold nanoparticle in small scale. Then we also study the morphology of the catalyst used and direct observe of crystal lattice in atomic scale. For X-ray diffraction, we characterization of photocatalyst phase. We study the crystal structure by identify the crystalline phases present in materials. Then we also study the chemical composition. Then I will explain the mechanism of photodegradation. Firstly, the electron will excited to the conduction band from valence band. This is happen because of the energy of the absorbed incident light is greater than the band gap of the semiconductor. After that, corresponding hole will form at valence band. The photogenerated electron and holes can be trapped under redox process. Formation of superoxide radical and hydrogen ion and dissolved oxygen in aqueous solution. Then the oxidation of electron holes will form hydroxyl radicals. Thus, the pollutants can degrade into non-toxic products. This is a diagram showing the mechanism of photodegradation. Next, we move on to the methodology. First, we prepare the photocatalyst. We synthesize both gold and titanium dioxide. Then we couple both of them together to form AU9 and AUN and TiO2 and AU101 and TiO2. Then the photodegradation of dyes. The last one is the characterization of photocatalysts. That's all from me. Thank you for watching.